Hi everybody, my name's Martin Pratchett. I'm the Engineering Practice Manager at Engineering New Zealand and one of the structural engineers. Yeah, we are happy to host in conjunction with Steel Construction New Zealand and the General Practitioners Group, Alistair, Fussell and Kevin Cowie from Steel Construction New Zealand. I'll be handing it over to you now, Kevin. Thank you. You're on mute, mate.
Okay. Thank you, Martin. Real pleasure to be able to give this presentation together with Alistair. I just want to briefly introduce Steel Construction New Zealand, and then I'll give some key industry facts, and then I'll hand it over to Alistair to give the rest of this presentation. So Steel Construction New Zealand, we represent the diverse New Zealand steel industry. From the mills who produce or manufacture the steel, to distributors who supply the steel, to engineers who design in steel, to the fabricators and erectors. So we're a member-based organization with over 360 company memberships, but as an organization we're quite small. So we've got 4 permanent staff, we've got 2 professional engineers and our general manager. So you'll see smiley faces there. On the left is Darren O'Reilly, the general manager, and then that's myself and Zahid Hamid as our other professional engineers. So at Steel Construction New Zealand, we spend a lot of time and effort to developing standards for the steel industry. We set a number of steel-related standards, including the one that we're going to be talking about today, which is the ASNZS 5131 standard. We offer a lot of services to engineers. We offer a technical help desk, able to assist you in design. If you've got a preliminary design of a multi-story building, we can assist you there. We produce a number of publications, designs aids. If you're a member of ASNZS, these are all free. And we also put on seminars and presentations. So if you want more information about what we do, head along to our website, asnz.org. Now some key industry facts, just to set the scene. We're really seeing a real increase in demand for structural steel solutions over the last 2 decades. And if you look at the multi-story commercial market, we'll see about 50% nationally in structural steel, and in Christchurch, in particular of the good performance of structural steel, is over 80% market share. We've grown in our output. Last year we manufactured and put in and constructed and erected over 100,000 tons of steel in the last 12 months. And this has been the output of about 114 fabricators. In terms of our capacity though, we haven't reached capacity. We have an estimated capacity of about 120,000 tons, and which could be increased if we went through a multi-shifting to meet demand. So there's plenty of capacity in the industry. We can do everything here in New Zealand. We're quite pleased to look in terms of our material certification that over 85% of steel used in New Zealand is third-party certified. So we've certainly worked in this area in the last few years, and we're pleased to report this. And similarly for our fabricator members, we developed an independent quality assurance scheme, the SFC scheme. Alistair will be covering this further in his presentation. And we've now got 44 fabricators who are part of this scheme, which represents over 89% of the sector's output. So these fabricators are representative nationwide. So with that bit of introduction to Steel Construction New Zealand, I'll now hand over to Alistair to take us through the rest of this presentation.
Well, good afternoon, everyone. Thanks, Martin and Kevin. This is really just a little bit of a roadmap of where we're going to be going in the next 40 minutes or so. I'll start with a bit of an introduction about the compliance topic. I'll then give you a bit of an overview of ASNZS 5131, which is hopefully what you're expecting to hear about today. And then the bulk of the time we'll spend, I'll be giving you, if you're an engineer, some tips on how you can get the quality of product you specify. And then at the end of the session, we'll wrap up with some just talking a little bit about some of the things that industry's been doing to support the implementation of ASNZS 5131. So just by way of introduction, I'd like to pose the question, could compliance be the next leaky building crisis? And my answer to that is, well, it could be if we don't manage the risk. And the reason I suggest that leaky buildings could be the next, compliance could be the next leaky building crisis is that we do have all the ingredients for the perfect compliance storm. We've seen globalization of construction product supply chains in the last couple of decades. That's increased the risk of non-compliance. Probably in the last couple of decades, we've seen supply of construction products coming mostly these days from Southeast Asia. Historically, we've seen it coming from North America, from Japan, from Australia. And so we've seen quite different supply chains. We also lack a robust compliance regime in New Zealand. We set a pretty low bar in New Zealand in terms of requirements for demonstrating compliance of products that are used in the construction sector. We allow essentially self-certification. We allow manufacturers to do their own testing and then self-certify their product. The final ingredient in the perfect compliance storm is that we actually also typically have a lack of technical expertise amongst the people who have a role in terms of establishing compliance of product, building consent officials, engineers and builders. These people are typically not materials engineers. They don't have fabrication, manufacturing type backgrounds. And as a consequence of this backdrop, the Steel Construction New Zealand's actually spent quite a bit of time and developed quite working on initiatives that are intended to address the compliance risk. We obviously have a vested interest in this. We want to make sure that people have confidence in our industry, that we're seen as a reliable provider of structural steel product. We also want to create a level compliance playing field. We realise that people not only get buildings fabricated out of structural steel in New Zealand, but also offshore. And we want to just make sure that regardless of where the steel comes from, that good processes are being followed to make sure that it's compliant. Just in terms of the aims of the presentation, they're twofold. Firstly, if you're an engineer and a building official, hopefully you'll get a better understanding of ASNZS 51, of the provisions that are intended to regulate and establish the quality of structural steelwork. The second aim of the presentation is that if you're an engineer, that you'll actually take away some ideas that will help you address some of the limitations that I'm going to highlight for ASNZS 5131 in terms of the quality management provisions. And as a result of doing that, you're actually going to get the quality of product that you specify. So that's enough introduction. Let's crack into thinking about ASNZS 5131. Hopefully, if you've an engineer, you're familiar with the standard, you're aware that it's ASNZS 5131 specifies minimum requirements for fabrication and erection of structural steelwork. It was published in 2016. There has actually been a revision, or a revision is in train at the moment for the standard. We should see sometime later this year revision to the standard. They're pretty minor in terms of New Zealand, the implications for New Zealand, but I will touch on one of the more important changes as we go through the presentation. So this document was cited as a verification method in 2018, so it's recognised as a means of establishing compliance with the building code. What I'd like to do in terms of thinking about 5131 is just discuss some of the key elements briefly of the standard. The first one is that it uses a risk-based approach. So it's not one size fits all requirements for in the standard. It uses risk-based categorization of structure or elements of structure into one of four categories. So at one end of the risk spectrum, we have CC1, which is the low-risk projects. These are really non-inhabited structures. CC2 would cover the majority of building structures in New Zealand. CC3 is when you're starting to get into the higher risk projects, the importance level 3 or 4. and the structures where they have seismic systems that have high seismic demand. One of the comments I'd make about the CC2 categorization is that probably for low risk buildings, the requirements in the standard are probably overly onerous. And as a consequence, it's worth giving some consideration. And I think with NZS 3404 potentially about to be amended, to thinking whether or not there could be almost a CC1 plus, which is really more low risk buildings. Because this is a risk-based standard, there are two types of provisions in this standard. Firstly, there are what I call general provisions that are applicable to all construction categories, and there's also construction category specific requirements. So some of the material traceability requirements, they become more onerous as the risk goes up. The weld quality management requirements likewise are construction category related. And it's the engineer who specifies the construction category for the project. The second element of ASNZS 5131 is that it includes technical requirements. So that it specifies minimum standards of workmanship. It gives tolerances for the work plumbness of a structure on site. There are surface roughness limits if the steel's cut. In the welding standard, there are various defect levels that have to be, that work has to comply with based on the weld quality categories. There are also fabrication limitations. So in the standard, there are limits on punching holes in steel. If you're using welding backing plates in a seismic application, well, the standard has specific requirements around how you have to detail the backing plane. The third element of ASNZS 5131 that I want to look at is conformance assessment, and this is probably the most relevant part of the standard that I want to give some thought to today, and I'll spend a little bit more time discussing it. So the structural steel contractor is required to document or develop, document and operate a factory production control system. So put simply, a factory production control system is required to regulate the quality of the output of a fabricator, and it also is intended to demonstrate conformity with the requirements of the standard. So just in terms of the details of that, all the fabrication erection activities in ASNZS 5131 have to be operated under a quality management system. So the fabricator will have to have procedures for all the key elements of work. They have to have competent personnel. So there are requirements around qualifications. They have to have fit for purpose equipment. So it has to be maintained. It has to be calibrated. There are requirements around managing the quality of welding. There's a requirement for documentation, so they have to have quality systems documented. They have to have a quality plan that's specific to a project. They'll create a lot of quality records as they go about operating their system, and they also have to undertake inspection and testing at various stages of the work. So why is managing weld quality so important? In ASNZS 5131, there in the 2016 version, there's an informative reference that weld quality has to be managed in accordance with ASNZS ISO 3834, bit of a mouthful there. In the new version, they've actually mandated that weld quality has to be undertaken in accordance with this standard. So why is welding such an important manufacturing process? One of the reasons that it's so important that welding, the quality of welding has to be managed, is that it's one of those processes where you cannot, after the fact, determine whether it's compliant or not, essentially without doing destructive testing on it, which isn't overly helpful. And so the way that the quality of welding is ensured is that the manufacturer or the fabricator has to control all the key elements that go into the welding process. ISO 3834 is an internationally recognized standard. It comes in 3 different levels: elementary, standard and comprehensive. So in 5131, the world quality requirements are related to construction categories. So for CC1, it's the elementary level, CC2 is the standard level, and for CC3, it's comprehensive. Kevin's already mentioned about the Steel Fabricator Certification Program in New Zealand. The local fabricators that are certified to the construction category 3 level are also audited and certified against the requirements of ISO 3834. So just to give you a bit of a feel for some of the items that are covered under this world quality standard, the fabricator has to have procedures for reviewing the contract documents, technical review. So the fabricator has to make sure that they actually have the technical capability to do the welding required. So they have to have the welding procedures, they have to have the personnel that have the appropriate qualifications to do the work. If they're going to subcontract work, they obviously need to make sure that they have procedures in place to manage that. So the subcontract is essentially seen as an extension of the fabricator. They have to have procedures for dealing with, in terms of having qualified welding procedures. They have to have competent personnel, both for welding, inspection and supervision. They have to have procedures around how they store and handle the welding consumables, and they have to have procedures in place for making sure that they maintain and calibrate their equipment. Everything so far sounds great. You're probably thinking, wow, this is awesome. ASNZS 5131 is the answer to all my quality prayers. I can rest easy now that if I specify to ASNZS 5131, it's all going to work out really well. Well, I'm sorry to burst your bubble. There is just one thing you need to be aware of, which is quite a significant limitation of this standard and pretty much all other standards, is that standards associations adhere to what they call this principle of neutrality, which means they write standards in such a way that conformity or compliance with the standard can be assessed by any party. So it could be first party, so that's the manufacturer, goes away, does all the testing, and then self-declares compliance, or it could be a third party. It could be an independent party that comes in, does testing, does inspections, and makes some declaration of conformity. And the reason they do this is that it's supposedly to avoid a technical barrier to trade. And so the principle of neutrality, so what? What does this actually mean in practice? The reality is that what it means is that the default requirement of ASNZS 5131 is self-certification. So the steel constructor goes away, establishes a quality system, they make their own self-assessment of their compliance with those requirements. During the process of a job, they undertake all the inspections and establish that it complies, because one of the things ASNZS 5131 doesn't do, it doesn't define the independence of inspection. So it doesn't actually say who should be undertaking the inspections. And the final step in the process is that the steel constructor then self-declares conformity, which is typically a producer statement, PS3, that they issue. What this does rely on is honesty and competency in terms of the steel contractor. And unfortunately, this principle of neutrality also applies to all the steel product standards, the plate standards, the section standards, the standards for supplying studs that are welded onto beams, the fastener standards, the welding standards. It's not just structural steel, it's any materials, constructional materials for that matter, that have standards, the conformity requirements. Once again, it's written in such a way that any party can determine compliance. So the challenge for the engineer is, well, I'm not an expert in fabrication, so how do I know whether the steel constructor actually meets the FPC requirements of ASNZS 5131? And then the following from that is, do I actually trust all the paperwork that I should get from the steel contractor? So in summary, the ASNZS 5131 quality management provisions are actually very comprehensive. And they're there to regulate and establish the quality of structural steelwork. Unfortunately, the principle of neutrality somewhat reduces or nullifies the effectiveness of some of these quality management tools. And as I've already alluded to previously, the building regulations don't address this deficiency. The bar is set pretty low. Self-certification is all that's required. As a consequence of this, the party that's probably best placed to actually address the limitations of ASNZS 51 are actually engineers, particularly in your specification. You have the opportunity to do some things that will actually give you a better chance of actually getting the quality of product you specify. And so in this section, I'm going to touch on make some suggestions, recommendation tips on what you could do in your specification. Just by way of introduction to these, I would just want to say that the recommendations that I'm going to present today, most of them have come out of or are based on a couple of documents that we've produced in the last year or two. The first is the New Zealand Structural Steelwork Specification in compliance with ASNZS 5131. We also wrote a Steel Advisor article, FAB 2001, which really gives a bit of an overview of the quality management elements that go into this New Zealand Structural Steelwork Specification. Today I'll also give some suggestions from what we present in Steel Advisor FAB 2001 for low risk projects. So really the key principles that sit underneath these recommendations, and the first one really is, and I've already alluded to this, nobody else is going to address the limitations of ASNZS 5131 other than the engineers. So my suggestion is that it's the engineers who really need to think about how to address these deficiencies in their specification, and also the primary tool that I'm going to suggest for reducing the compliance risk is the use of third-party conformance assessment bodies to assist the engineer. So this is fabrication inspectors, welding inspectors, test facilities that take test samples from steel and undertake testing. I have 6 tips, 6 recommendations today. And the first one is, my first suggestion is that as engineers, you should really focus on materials and welding. If you were unlucky enough to be an engineer on a job and you had essentially all the steelwork arrive from somewhere, it turned up in a container and it had a bit of paperwork sitting in the corner of it, and you knew nothing about the origin of that steel, you wouldn't be able to figure out whether the materials all the welds were actually up to standard unless you did destructive testing on them. Pretty much everything else you could figure out by visual inspection, you could do some measurements on site, and you could detect the rest of the issues. So my recommendation is focus on materials and weld quality. Second tip is impose steel constructor qualification. So really what you're trying to do is weed out undesirable fabricators. These are cowboys. As an engineer, you're often quite removed from the fabricator selection process, so you need to have some requirements in your standard that'll actually provide some sort of filter in terms of who gets selected. This is an example over here of a piece of steel. This was a portal frame that was actually erected on a site in Auckland. And I tell you what, it's not a great weld. I'm not sure I could do better myself, but then I'm not a qualified welder. So this was a job. Hopefully it's none of your jobs, and I suspect it ended up having a bit of rework. Now that's not the sort of fabricator you want working on your job. So what I recommend in terms of qualifications is that for your high risk project, CC3, that you look at having some form of certification requirement for your fabricators. So there are recognised fabricator certification programs. We have one in New Zealand, there's one in Australia, for Europe they have one, the Americans have one, or that you have a fabricator that has certification to the world quality standard ISO 3834. So there's certainly international operators that do that. The second option that would be appropriate for perhaps your lower risk CC2 project is that you do a desktop review of a compliance document. So in your specification, you require the fabricator to supply a compliance document, which essentially demonstrates that they comply with the construction category requirements at tender time. You might need somebody to help you review it, so you might need the services of a fabrication or a welding inspector, and certainly I'd suggest you also have in your specification that it's subject to your approval that such fabricators are appointed to your project. The third recommendation, and this is really if you have a very simple project, so this is what I described before as the CC1 plus type project. So this is the very low risk residential type project. A very simple thing to do is that you could prepare a very simple checklist. It could be based on Appendix D of the welding standard ASNZS 1554 Part 1, where it has in there things that matters to be resolved between the engineer and the fabricator. This is around the qualifications of the welders, the supervisor, the inspector, the qualifications of the welding procedures. Suggest you put together a simple checklist, and you require that the fabricator gets an independent qualified welding inspector to go into the workshop. They audit the fabricator against your very simple checklist requirements, and then at the end of it, they give you some written feedback as to whether or not the fabricator complies. And this approach is probably quite suitable if you're working in provincial New Zealand. You will probably find that a lot of the time you're not necessarily dealing with specialist structural steel fabricators. You'll get some perhaps have general engineering companies that might sometimes they might do trailers, they might do fences, they might do other sorts of work. They don't necessarily specialize in structural steel. So you at least want to make sure that the key welding requirements are actually complied with. Now, if you find that there are some deficiencies for these very low risk projects, for example, lack of qualified personnel, the fabricator can actually contract personnel. That could be a welder or welders. They could also they could engage a qualified welding inspector who can supervise and inspect the welding. I had a project, I'm based in Hawke's Bay. I had a small project last year. Had a company, they're actually a good engineering company. They do stainless steel, they do pressure vessels, so they certainly have very competent welders, but they do very little structural welding, and they knew that they weren't familiar with the welding standard, the fabrication standard, so they engaged a welding inspector who was appropriately qualified under 1554 to supervise and inspect the welding for the project. And at the end of the project, they gave me a note just to advise that all the welding complied with ASNZS 1554. So I was happy with that. You could also find that there might be a lack of qualified welding procedures. The fabricator needs to go off and get them qualified. The 1554 Part 1 has requirements around how you actually qualify welding procedures. Once they've qualified their welding procedure, they should get a weld procedure specification. I have an example over here. This is really like, it's their recipe. It's what they have to use. Once they qualify that procedure, they then have to use it once they go and start your job, and any other time they need to have they have similar types of weld procedures. This will essentially specify all the key requirements of their welding. So all the geometrical set out of this weld, the range of amperage, the range in terms of thickness that is covered by this procedure, and you should be supplied with a copy of it. If you're not sure what it all means, send it to the same independent welding inspector who did the audit of the company, just to give you peace of mind. So they should be able to have this. The one thing you do want to make sure is that once they've actually gone to the trouble of getting it qualified, they actually use it. Unfortunately, some companies have a whole lot of good welding procedures, and they sit in the cabinets, and the welders just go merrily away and do their own thing when they go to weld, and that's not good. So make sure that if you do pop into the workshop that you check to see that they're actually using their weld procedure specifications. So the third tip is to specify independent inspectors. ASNZS 5131 requires a number of processes in the fabrication erection processes to be inspected. And as I mentioned before, ASNZS 5131 doesn't actually address the independence of inspection, doesn't say who should be undertaking the inspections. Historically, in terms of New Zealand fabrication inspection practice, what we've seen when it comes to welding, typically the visual inspection, so this is where the inspector is just taking a look at the weld, making sure that it's the right type of weld, that's the right size, particularly if it's a fillet weld. They're looking for surface defects. Typically, if the fabricator's had a qualified in-house person, it's been taken, they do it in-house. Typically for the non-visual, which is your radiography, ultrasonic, magnetic particle, that would be outsourced. When it comes to coatings, it's always been dependent on, in terms of the independence of the inspector, has always been dependent on the surface preparation. Is it abrasive blast or is it just being wire brush? And also on the corrosion environment. So where you have to have really good preparation, you've got a highly corrosive environment. Typically what's been done and what's recommended ASNZS 2312 is that you have an independent coatings inspector. And the remaining inspections would be undertaken in-house. What we're recommending is that in your specification, essentially you increase the use of independent inspection as the risk increases. So as you have fabricators that are perhaps you have less confidence in, they're not certified, or if you have projects where the project risk is high, it could be CC3, we certainly recommend using more independent inspection. I suggest that you refer to our New Zealand structural steelwork specification. We actually have specified in that document the independence of inspections for all the key inspection tasks in 5131. We've related it to whether they're a certified fabricator, whether they're not, and what construction category it is. For CC1 plus, which is this is very simple, structural fabrication. One suggestion is that you actually allow the welding supervisor to inspect the welds if they're appropriately qualified, if the work is simple, and if you trust the company. So a good practice typically is you separate your welding supervision from your inspector, and that's really just to give some independence. Even if it's done within the same company, it's the same principle typically as you try and have different parties. That's not so important if it's a really simple project. Fourth tip is, and I know engineers are loath to do this, you were sort of time poor, is that you really should review some key documents. ASNZS 5131 requires quite a lot of documentation. As I mentioned before, fabricator has to have a documented quality system, they'll have to have a quality plan that's project specific, at least for CC3 or CC2 if the engineer asks for it. They'll produce shop drawings, and that really depends on how complex the project is. If there's any automated fabrication going on, you'll typically find that they will have to develop a shop drawing. There'll be an inspection and test plan, and there'll be loads of manufacturing data. There'll be literally hundreds of pages that the fabricator will generate. These will be all the material certificates, their inspection reports, their checklists, etc. There's way too much in there. You don't want to review it all. But I am suggesting that you give some attention to reviewing some key documents. So what am I going to suggest you focus on? Well, firstly, I think you should focus on, have a quick look at the inspection and the test plan, that you look at the material test certificates, and you should also have a quick look at the weld inspection reports. So the inspection and test plan essentially lists all the inspection tasks in the sampling regime that is going to be used by the steel constructor for each of the inspection tasks. It will include acceptance criteria. It will also say when it needs to be done, particularly with welds. There could be hold points and who has to do it. So I have over here an example. I'm sorry, it's a bit hard to read, but let me just take you through this. This is, for example, here's some non-destructive testing. So this is for the welding. You'll notice in here they say NDT as per the specification in construction drawing. So they picked up that the engineer obviously has some requirements in their welding specification. Under their acceptance criteria, they make reference to in ASNZS 1554 Part 1, Table 6.1 and 6.2 and 6.3. So in those tables, they will have acceptable defect limits for the different types of the weld quality categories. So the fabricators noted those. They also have in here listed who needs to be involved with various inspections. So you see in here, this is your supervisor, welding supervisor. They have to review the welds. You see here, this is your welding inspector. Their job is to perform the inspection. So they will have to inspect in accordance with 1554 Part 1, specifies what the inspector has to do and the details of the inspection report. And you can see there's no role there for the client's representative for doing any non-destructive testing. So the inspection task list will be a mixture of what you put in your specification. So if you have requirements around welding and coatings particularly, they will turn up and should end up in the inspection task list. They'll also, what you don't address should be covered under their standard operating procedures. So they'll have default inspection requirements of their own that they will use if you don't tell them anything else. So what's the value of the ITP? Why am I suggesting that you spend, probably wouldn't take you that long to do it, but you do this review? Well, firstly, you want to make sure, did the fabricator actually read your specification? And secondly, even if they did they correctly interpret it? One of the challenges with the risk-based approach in the back of ASNZS 5131 is that it can be a little bit complicated for the fabricator to work out the requirements. So if it's a seismic situation, you have seismic demand categories, you have, what is it, can't remember what the other one is, there's another factor in there. So they actually have to go through and there's a bit of a risk matrix, and then they have to figure out for all the different types of connections what the sampling regime is. So you might want to just have a quick look to make sure they understood that table and have applied it correctly. I was listening recently to a presentation that was given by Andrew Boyd of Auckland Council to some engineers, the Auckland Structural Group. And one of the questions that was raised in the Q&A session by the engineer, who was commenting on the fact that he had a job and he wasn't happy with the amount of non-destructive examination that had been undertaken by the fabricator at the end of the job. Now, if that engineer had actually asked for an ITP and reviewed it before the job even started, he would have known exactly what sampling regime that fabricator was going to use. So they would have actually found out if there was a bit of a disconnect between their expectation and the fabricators very early in the piece. And I'm going to suggest that really for the very simple CC1 plus projects, you don't need an ITP and you don't need to review one. I mentioned before manufacturing data. Screeds of this will be generated during this job, during a job, particularly if it's a complex one. My suggestion is that what you want to look at is the material test certificates. This is for the structural steel products. I also recommend that you review it prior to fabrication. I don't know how many times at ASNZS we've had situations where the engineer has waited till it's code of compliance time. They've been asked to supply one and then they've gone, oops, better have a look at some mill certificates. They've asked the fabricator for it. Oh dear, there's a problem. Not a good time to find out you've got a problem. So my suggestion is that you ask to get your mill certificates prior to fabrication. What you're really looking to do is check sizes, grades, and really quite importantly, particularly if you've asked for certified product, you want to make sure that they are supplying, they've got product from a manufacturer whose product range is certified. The second item that I suggest you look at are the weld inspection reports. I wouldn't suggest you troll through all the pages of those reports. What I'd look for is just at the front of each report, there'll be a summary statement. What you want to do is just have a look at that. What you also want to do is just make sure that the weld inspection reports cover essentially the quantum of the work and also that they cover the really key connections. So if you've got presumably some hard-working seismic frames, I would be homing in, making sure that you can see weld inspection reports for those really critical welds. The fifth tip is in your specification, require good sourcing practice for raw materials. And I recommend that you use the requirements of our Steelwork specification. So in that, we essentially say that for steel products, that's sections, plates, etc., hollows, that they're sourced in accordance with our New Zealand Guide to the Sourcing of Compliant Structural Steel. So that would be your CC2, CC3 projects. And I'm going to give you a quick overview of that document. Next slide. For simple projects where you've often just got a handful of notes on a drawing or perhaps a one-pager, you can really essentially just put a note saying you want all third-party certified product, either ACRES or BSI. And the reason that you can do that is that pretty much all the range of product that you will use in those small projects will be covered by third-party product certification. So typically all the hot rolled sections will be covered, small size hollow sections. The only exception, which Kevin reminded me of this morning, is that sometimes you'll find with small angles, they won't be covered. But typically small angles are used as secondary elements. I wouldn't be too concerned about whether they are certified or not. So in terms of this guide, why did we produce it? Well, we're obviously keen to reduce the compliance risk. As Kevin has said, over 80% of the structural steel that's supplied to the New Zealand market is covered by product certification. The reason we developed this guide was just to give some pathways for demonstrating compliance for a non-certified product, particularly if you have a high-risk project. So the guide uses a risk-based approach in terms of demonstrating conformity. So it considers the project risk, which we've already discussed. That's keyed into the 5131 construction categories. We've also developed a steel source risk categories, 1 to 4. And in terms of these source risk reliability categories, the way that we've categorized steels is really comes down to what role have third parties played either in auditing the factories and making sure that their factory production control systems are appropriate and have audited and certified them, or have third parties been involved with actually doing independent testing of product. So the most reliable product is source reliability category 1. That's product that's covered by a robust product certification scheme. The least reliable, or the source reliability category, is category 4. So that's a steel maker. No third parties have been involved. They haven't had anybody come in and look at their quality controls or their factory production control system or their product. These people essentially self-certify the quality of their product. Even though the guide's about 50 pages, you can actually distill the document down to 2 pages. There's 2 flow diagrams. The rest of the document is really just explanation that will help you understand this diagram if there's some things you don't understand. So this diagram there are 2 of them. One's for construction category 3, one's for construction category 2. And you'll see in here as you come down, here's your steel source reliability categories. So over here, this is your robust product certification scheme. Over here, this is your least reliable source, source category 4. So essentially what you do is you come down here. This is really the critical part of the diagram where you're answering the question, is any independent testing warranted? If it's a product that's covered by a robust product certification scheme, the answer will always be no. If you've got a project where it's high risk, your high risk materials, you'll find that there'll be a requirement to test. So in this flow diagram, we not only say whether you should be testing, but we also have developed some sampling and testing plans. So as an engineer, you don't even have to dream them up. We've also got some sampling regimes. So we actually specify how often they should sample. And then we've also got some requirements around what the inspection reports and the supply declaration of conformity should look like once the importer has gone through the process. We also have in there a discussion around what evidence should be supplied with the product. So once somebody's followed the guide, they've met the requirements of it, what paperwork should be supplied with the steelwork or the steel. Not only do we suggest good practices followed for sourcing your structural steels, but also the fasteners and the anchor bolts. And what we recommend is that for your critical connections for CC2 to CC4 projects that you want to have independent verification testing undertaken. Now we've developed some Steel Advisor articles, MAT 1010 and 1011. We actually have specified some sampling and test plans for bolts and for anchors. We do actually now consider them to be overly onerous. If this is a regular supplier, they'd be more appropriate, the sampling levels in there, as if you had a first-time supplier. We will be amending those Steel Advisor articles in light of the fact that we are currently working on a bolt importer charter, and once we launch that charter, we will be updating those Steel Advisor articles. So why is it that we're recommending that for your critical connections that you should have some verification testing undertaken? Well, the first reason is that there is none of the product that's supplied to the New Zealand market is covered by a third-party product certification scheme. All of it comes from Southeast Asia. The anchor bolt standard DIN 976 Part 1 has actually no mandatory conformity assessment requirements, no requirements for the manufacturer to operate any systems to control the quality, no mandatory testing requirements. Furthermore, there's lots of manufacturers. It's bought on price, not quality. And so these items represent the high-risk compliance items, and hence we recommend for critical connections that some testing is undertaken on the fasteners. The sixth tip or suggestion is that you anticipate offshore fabrication. And what I mean by that is that unless you're only involved in very small projects where it's just not worth the time, effort and hassle of a builder or a developer to consider offshore fabrication, that you're going to end up at some stage having to deal with offshore fabrication, or at least a client or a builder that shows some interest in doing it. My suggestion is it's better to front foot it. It's better to address it in your specification, even if most of the time it's never required. ASNZS has had a number of engineers come to them when they're in a bit of a pickle. They've had a job, they specified it in ASNZS steels, they specified it to all the New Zealand, Australian welding, fabrication standards. They assumed that's what would happen. The client signed up a builder who had come in with an offer from China. They'd agreed all the terms and conditions of that. The engineer was not involved in the process, and they were actually on the back foot from day one in terms of trying to manage that process. And at the end of the day, they were left carrying the baby, having to sign it off at the end of it. So my suggestion is, rather than being on the back foot reacting to that you actually address it in your specification. Just some of the things that you perhaps just to note about offshore fabricated product. What you'll typically find if somebody takes your job off to China, the Chinese fabricator is going to want to swap all the steel sections that you've detailed, ASNZS steel sections, for Chinese grades of steel. So that means that for you as the engineer, you're going to have to redesign the section. So you may well, in your fee proposal, want to make sure that you put the tag in your fee proposal that you've assumed that it's going to be fabricated locally, and it'll be ASNZS steels. And if it goes offshore, it will inevitably involve a lot more work on your behalf. So my suggestion is that you have some room to renegotiate the fees. You may well have heard people talk about these really cheap, too good to be true offers for Chinese steels. Just be aware you're getting what you paid for. These will be the low tier fabricators. They will be offering Chinese domestic market quality. They won't be to ASNZS 5131. The experience we've seen with when you get the top tier Chinese fabricators operating that are actually producing steel to international standards, using proper procedures to manage quality, their costs are actually quite similar to the local fabricators. So it really does show that it does actually cost money to manage quality. So in terms of matters to consider in terms of offshore fabrication, you need to think about, will I allow a change of standards? Will I allow them to change the product standard or the fabrication standard or both? but just be aware that's an alternative solution. That's not a verification method, and so it's going to require somebody with specialist expertise, and it won't be, most structural engineers in New Zealand won't have it, has to make an assessment that the use of these standards with NZS 3404 is okay, that they're compatible with the assumptions and the requirements of the standard. So firstly, in terms of the design assumptions, when they did the calibration exercise to work out all the strength reduction factors in NZS 3404, they made assumptions about geometrical properties of the sections. They made assumptions about the weld defect levels that will be tied into the weld quality categories in 1554. The other thing that needs to be considered is that the NZS 3404 material selection to avoid brittle fracture provisions, they are based on Australian steels and test data from Australian steels. So they are not, they will not be reliable if somebody needs to select materials for other standards. When it comes to welding, ASNZS 1554 Part 1 is essentially all the preheat requirements. The methodology that was developed for that was based on Australian steels manufactured to Australia, New Zealand or Australian standards. And such steels are called qualified steels. You can weld non-pre-qualified steels to 1554 Part 1, but you have to re-qualify your weld procedures, and it is a more onerous process. So for a start, somebody has to come up with a method for determining the preheat requirements. You have to have come up with a way of matching welding consumables. And when it comes to qualifying the welding procedures, if it's a non-pre-qualified steel, there are additional mechanical tests that have to be undertaken. My suggestion for you as an engineer, and given that particularly if you're a general practitioner, you're not a specialist, is that you have a requirement in your specification that if somebody wants to go offshore, whoever it is, has to actually engage the specialist expertise. They have to address the matters. They have to be willing to approve the use of such standards as compatible with NZS 3404. And if this change to offshore supply occurs after a building consent has been issued, then there's going to have to be a revision to the building consent. Some of the other suggestions for addressing offshore fabrication, I would have a requirement in there that a trusted third party has to actually go in and do a factory audit to see the fabricate, regardless of if it's China, Thailand, wherever it is. Somebody that you trust has to go in and audit them against the requirements of ASNZS 5131 and give you some written confirmation that they comply. I also recommend that you require trusted independent inspections of critical processes, and I would consider those to be things such as the material sample collection. So somewhere in China there's going to be a steel mill. You want to have somebody you trust who goes in and oversees the collection of the samples and make sure that they get to the test facility. They have very good test facilities in China. You can't always be confident that what they actually tested was from steel in your project. So that's one process. The other one is you want to have that trusted welding inspector all over the welding operations. You want them to be there preparing the welds, during the welding, and doing the post-welding inspections. And a final suggestion is when what will be required to release the steel from essentially to get it shipped, they'll require 100% payment. Once that money is received, there's no comeback on that steel. So my suggestion is that you get your trusted party to inspect all the steel before it goes into the container, and they provide written confirmation that it complies with the requirements before it's shipped. I also recommend that you use Australian or New Zealand inspection companies. There are many local inspection companies in places like China, and I wouldn't trust them. You can't guarantee you're going to get a good outcome from using them. And the reasons for that is essentially cultural factors. One is there's been corruption, and one of the other factors is they are a culture that respects age. So if you have a young inspector goes into a workshop and they won't fail anything if an elderly grey-haired senior management comes down and puts pressure on them on the workshop floor, they won't fail it. So you can't rely on local inspectors, even if they work for reputable international companies. If you want to use international companies, you make sure that they get somebody from Australia or New Zealand to go over to look at your project, or use a company that's or use expats that are based in that country. That's your best chance of getting a good outcome. And we actually have in the Steelwork specifications some requirements for inspection personnel for offshore projects. My suggestion is you have a look at that to give yourself some ideas of what you might put in your specification. So we're in the home straight now. What I'd like to do now is talk just a little bit about what ASNZ's been doing to support the implementation of ASNZS 5131 in New Zealand. And the first thing I want to touch on is engineering training. So today we've really given you a bit of a whistle-stop tour of 5131, giving you some high-level recommendations around what you can do in your specification, but we really haven't gone into too much detail. If you're an engineer involved with construction monitoring, we're running a 2-day course, and this course will be ideal for you if you're feeling that you perhaps are not that confident or competent in terms of understanding structural steelwork, processes, etc. that go on, and what can go wrong and what you need to look out for. Certainly suggest that you attend this course. It's a 2-day course. It'll be run, the first day will be in October, the second day will be in November. Because welding is such an important part of the fabrication process, we're dedicating a whole day to that. So watch the space. We'll give you some information when we've confirmed the dates. We've also got some upcoming webinars next month. The first one, well, I don't know if it'll be the first one, but the first one I'm going to talk about is stud welding. We've just developed a new fact sheet on stud welding where we overview the key quality management requirements of ASNZS 1554 Part 2. We also discuss roles and responsibilities for the builder, the stud welder, and the engineer. We're also going to be running a welding course we're talking about welding, particularly from an engineer's point of view in terms of specifying weld. So we'll be thinking about when would you specify the different types of weld quality categories, and when might you call up fillets, partial pen and full pen butt welds. What are some of the pros and cons? When might you specify them? So that's something to look out for as well. We've been pretty active in the last several years in developing publications. We've referenced a number of them today. What we've done to help engineers and building consent officials, etc., to perhaps understand or be able to get access to some of these documents, we've actually developed what we've called the Compliance Toolbox fact sheet. It comes in both a hard copy and it's also online. And so the good thing is that if you go onto our website, you go to the Compliance Toolbox, we have links to all the documents that we reference, all the documents that we've discussed today are available on the website. So I certainly encourage you to go, Kevin's already mentioned, www.asnz.org. Kevin's mentioned that we've had some steel industry quality initiatives. So I want to just quickly give you an overview of those. Hopefully you're very familiar with our steel fabricator certification scheme, and you're all specifying that you want certified fabricators for your projects. The scheme was launched in 2014. What this is essentially it's independent expert assessment of the compliance of a fabricator with the ASNZS 5131 construction category. So they get certified to a particular construction category. The certifying body is Harris Certifications Limited, so there's a governance structure that sits in behind this certifying body. Companies get certified for a 5-year period, and they have annual surveillance audits. Back in 2014, when we launched the scheme, there were 8 steel constructors certified under the scheme. We now have 44. and the numbers going up by the day. They represent about 85% of the New Zealand industry by output. If you want to know who's a certified fabricator, where to find them, go to www.steelfabcert.co.nz. We have pretty good coverage these days of New Zealand. Obviously, we have the main centres, Auckland, Wellington, Christchurch. We have them in Dunedin. We have them in Balclutha, Queenstown. We have them in Palmerston, Hawke's Bay, even Gisborne has them. We have them in Tauranga. Last year we launched a charter scheme for our steel distributors. I don't know if you appreciate, but pretty much all the structural steel that's used in New Zealand building and infrastructure projects is imported. We have a very small amount of product that comes into that market from via New Zealand Steel. They're a plate or a coil mill, so everything, all the product they produce is flat. Some of their product is used as plate, and some of it gets to market as welded sections through their Steltec business. They pretty much, most of the product that comes through the steel importers, probably over 60% of it would come from Australia, and the remainder would be from Southeast Asia. And because these days they're sourcing with the global procurement, it's become more risky in terms of sourcing. These importers have to be more sophisticated in their procurement. And so we've developed this charter to essentially reward and promote good procurement practice. So we've developed some implementation rules. There are audit requirements in those rules, and the 6 companies that have been chartered all had to be independently audited, and we need written confirmation that they comply. So if you want to find out a little bit more about the charter scheme, go and look at our website. We have a fact sheet, gives you a bit of an overview of some of the requirements. So some of the key things in there, for example, they have to have procedures for doing due diligence if they're looking at getting a new supplier. They have to have some procedure there for monitoring the quality of their regular suppliers. So they have to engage a metallurgist to get them, help them set up a testing regime or a quality control regime for each of their steel suppliers. We're also working with the bolt importers. We've been investigating the idea of developing a charter with a working group. We've had 6 bolt importers. What we've come up with is essentially something that's based on the principles of the Steel Distributor Charter. We've developed some implementation rules, and we're now in the process of inviting companies to sign up. So we're hoping that we'll have some good news to announce about the charter when we can expect to see that launched. And that's the end of my time. So I haven't actually been checking to see whether there's any questions come up. So I'll hand you over to whoever's got the moderator of all the questions.
That would be me. Thank you for that one, Alistair. We'll start from the beginning. There's actually very few questions so far. We've got 3, in fact. And so the first one is it correct that section 4.5.2 states that a quality plan for CC2 is only required if called for in the construction specification?
I think that'd be correct. Yep. So if you're an engineer and you want to get a quality plan, you can ask for it in your specification, but it's not mandatory.
Great. And does the master specs suite include the recommended FPC procedures?
Well, I'll let Kevin answer this one because I know ASNZS's been discussing with master spec about them adopting the ASNZS specification or in some way, shape or form.
Yeah, so you guys can hear me? Yeah, yes. I'll just further to what Alistair says is we've been in discussion with master spec, so we're about hopefully to sign up a memorandum of understanding where they're going to incorporate the what was that? They're going to incorporate the New Zealand Standard Steelwork specification, the ASNZS specification, into their document, and so they'll be clearly labelled as an ASNZS spec, and they'll be made available to all ASNZS members as well.
Great. And the last one that we have is, how do I find a list of NZ Weld inspectors and third-party specialists for offshore inspections, especially now that travel is limited?
Gee, I don't know, Kevin. I don't know if you know the answer to this one. I mean, there's the usual suspects. I mean, there's people like Southern Quality Assurance have done lots of work up in Southeast Asia for New Zealand. Probably any of the main ones, SGS, they have offshore offices, I'm pretty sure, and have done work. So there are a few. That's probably the ones that immediately spring to mind. So I don't know if there's a list somewhere of them. I don't know, Kevin, if you can think of where there might be somewhere.
Yeah, no, I'm not aware of any list. I just know the two that Alistair mentioned. I can't really add anything further to that.
All right, and nothing else is coming, and I can't see anybody typing in there, so it looks like that's the end of the questions. Thank you very much, and I understand that, Kevin, you're going to be presenting next month on the weld detailing. Alistair, are you going to be on that one as well?
Probably
Yes.
not sure. I'm not sure. We haven't actually talked about it, to be honest.
Yeah, so yeah, we're not sure. We're just developing it at the moment. Certainly, you know, we work closely together, Alistair and I, and so yeah, we'll see who delivers it in the end.
Right, and so that will be advertised on the Engineering New Zealand website, and just keep an eye out for it if you're interested in attending. Thank you very much for your time, both of you. We really appreciate your contributions, and we will see you in a month or so.
Thank you.
Well, okay, see ya.
Thanks. Bye.